Welcome to Measurement Computing. I prepared a short example to show you how to use the USB-TEMP with DASYLab, acquiring and logging data to a file. In addition to this example, we've posted a set of examples at www.mccdaq.com. If you have any questions, please feel free to contact us. The first step when configuring a new application is to verify the hardware. First, I'll run Instacal. Instacal will detect and allow me to configure any measurement computing hardware on the system. I've detected a USB-TEMP. Click OK. Now click the Configure button. I can see that I've previously configured this USB-TEMP with a thermistor on the first two channels and a thermocouple on the second two. I'll click OK, and I'm not going to calibrate it. Now click the Test button to verify all the channels are reading correctly. I know that I have 4 channels that are not wired, and I'm reading appropriate data on the first 4. I'll click OK and close Instacal. Now I can run DASYLab. When DASYLab starts up, I can create a measurement computing analog input from the MCC-DRV group. I need to select the module, drag it out, select the channel group, and double-click on the module to configure its properties. I want to configure all 4 of my activated channels, and now I want to change these channels to read degrees Fahrenheit. I need to do that for each channel. When I've done this, I'm going to name each channel. I'll name channel 0 as position 1. Channel 1 is position 2. Position 3. And finally position 4. This just enables me to identify which sensor I'm looking at. Now click OK. When acquiring temperature data, I often want to do an average function to smooth the signal. I'll go to the data reduction group and drag out an average module. Double-click on it. First add the additional channels, and I want to configure it so it's an arithmetic mean moving over 10 samples. That's 5 seconds worth of data. I know a shortcut. I'll click the F8 key to configure all the channels identically. They're now all moving averages at 10. The next step is to create a display module to see the data. So I'm going to go to the display group and drag out a digital meter. Double-click on it. Add the additional 3 channels, click OK, and connect it up. I'll use the Restore button to display the digital meter on the screen. Now hit the Start button, and you can see that you're reading the data between 71 and 76 degrees, depending on where each of the sensors is. Now click the Stop button. I'll minimize the digital meter to get it out of the way. I want to add a thermometer type of display. I'll do that by first double-clicking on the digital meter, selecting Copy Inputs. This lets me keep my worksheet neat by allowing me to daisy chain. Now drag out a bar graph module and double-click on it. Add the 3 channels. This time I want it to be a thermometer type of display. And then I'm going to click on the scaling button to scale each of the channels between 50 and 100 degrees. I'm going to take advantage of the F8 key again to configure all of the channels. Now checking my channels, I can see that these are not yet configured as thermometers. I'll go back to channel 0, click the F8 key to copy all the settings, and now I have them set up as thermometers. Click OK, wire it up, restore all the displays, and now you can see the bar graph display has got a thermometer-like display. I've arranged them side by side. I'll rearrange and then press the Start button. Now you can see the bar graph has got the channel name on position 1, 2, 3, and 4, and it's displaying the scale for each of the individual channels. Click the Stop button. and minimize the displays again. The next thing I want to add is the ability to show a graphical display. I'm going to do the same thing I did with the digital meter. Double-click on the bar graph, click on Copy Inputs, and click OK. Next, I'll drag out a chart recorder. The chart recorder, when you double-click on it, needs the additional 3 channels, and then I'm going to configure the Y scaling. I want to use the same scaling, so I'll use 50 to 100. I'll click F8 to copy that to all 4 of the channels, and then I'll verify it and click OK. Reviewing the configuration reminds me to look at the X scaling. The module defaults to 60 seconds worth of data. When you're looking at temperature, you're often looking at a larger period of time, so I'll enter 6,000. But then I'll configure a zoom window of 60 seconds worth of data. Click OK, and then click OK, and restore all the modules up. This time you can see that the recorder was really big, so I need to rearrange it, make it smaller, and to fit into the area. I'm working in a small window for this video, so I'm going to make some of these other displays a bit smaller as well, to be able to fit into the area that I'm showing you. Now you can see that I've got a recorder module, the bar graph display, and the digital meter display. I'm going to click the Start button, and it says I haven't wired up my recorder. So I'll minimize the recorder and wire it up, restore it, and then click the Start button. That's a common error. All DASYLab modules have to have connections going into them. You can dangle the outputs, but all inputs have to have connections. You can see that we're now measuring the temperature. If I apply some heat to one of my thermocouples, you can see that it's responsive. It's going up as I heat it. And now I'll apply some heat to the second one. You can see that this is responsive and it's real time. This is a nice looking display, but we're not done, so click Stop. What's next? I want to log data to the hard drive. You need to first minimize the windows and then go back to the recorder, click on Copy Inputs, and click OK. Now I want to add a module from the Files group called Write Data. Until you add this module function block, you're not logging any data to the hard drive. Double-click on it to add the 3 channels for a total of 4. Now DASYLab defaults to the DASYLab binary format, but today I want to store ASCII data. So select ASCII. This is creating a readable text file. I know that from some experience, in order to work well with Microsoft Excel, that I need to change the ASCII properties. I want to change the data format separator to tab, and then I want to store 3 decimals worth of data for each of the channels. And I want to store the time format not as hours, minutes, seconds, but rather as date and time. It's going to store in the Windows format, and it's going to include the header, channel names, and a time channel. Click on the OK button, and now click on the File Name button, and let's call this file Logger. It'll be logger.asc, where ASC means ASCII. I want to save the file every 1 block to make sure the data is secure, and I want to append to the existing file. That way I won't accidentally overwrite it. It'll just keep adding data to it. Click OK and connect it up. Restore the displays and click Start. Now I'm actually logging data to the hard drive. I'll log a couple seconds worth of data. And then I'll click Stop. Now minimize DASYLab. Let's look at the data file. The DASYLab data is stored in a data folder in the Public Documents folder. Open the Public Documents folder, and the data has been stored in a data folder. I've just created Logger .asc. Right-click to open it with Excel. I've previously done this, so Excel is configured on the computer to be able to open the ASC file. Now I need to rearrange Excel to fit on the screen. And you can see that Excel is showing you the header information. It's got the date, it's got the time. It's displaying minutes and seconds and not the full time. It's showing me that I am collecting data twice a second, 0.0, 0.5, and each position I'm reading degrees Fahrenheit. You can see it's correctly logging to the hard drive. I want to show you how to change the time column from the Excel default. So select the entire column and right-click on it, go to Format Cells. And in the Format Cells dialog, I need to use a custom format for this data. The custom format I want will start with the hours, minutes, seconds, but I need to modify it by adding a 0 to display the complete timestamp. Click OK, and you can now see that Excel is correctly showing you the hours, minutes, seconds, and fractions of a second. You can scroll down, and you can see the data has been logged every half a second with up to 3 decimal places. So in summary, this has been a hands-on exercise on how to store DASYLab. The USB temperature device is a very reliable device, and DASYLab allows you to work with it quickly and easily. Thank you for your time today. You can find this example and other examples at our website at www.mccdaq.com/DASYLab.